Hello everyone. So today we'll be talking of heat exchanger, which is a type of the counterflow heat exchanger. So this question was asked in GATE 2020 Set 1, in which the examiner has asked about the concentric tube counterflow heat exchanger and the two types of the fluids which is entering. One is the hot oil and the another is the cold water. So the hot oil enters at 102 degrees Celsius and leaves at the 62 degrees Celsius, while the cold water enters at 25 degrees Celsius and leave at 42 degrees Celsius, right? And what we have to find, we have to find the log mean temperature difference, that is LMTD, right? And we have to calculate it near to 1 decibel place, right? So before solving on to the main question, let me just give you the brief concept behind it. So I guess you all are aware about the type of the heat exchanger, like the parallel flow heat exchanger or the counterflow heat exchanger, right? So in case of the counterflow heat exchanger, if I draw the diagram, just a second. So at this point, let us suppose our hot fluid enters, and at this point, this is the exit point at which the fluid gets exit, right? And one more, this is the second inlet space, right? And if we denote it, this is the temperature Thi, this is the temperature Tce, this is the temperature The, this is temperature Tha, right? And their difference in their temperature would be delta Ti, and in case of the hot exit to the cold inlet, it would be delta Te, right? Where if I'll tell you where this delta Ti would be Thi minus Tce, right? And delta Te, if you find out, it would be The minus Tsi. Right, now what the Thi is? Thi is the temperature at which the hot water enters, right? Temperature at which hot water enters, and similarly for the Tci, it would be temperature at which cold water enters, right? Similarly for the The and Tc, it would be temperature for the hot air and the cold water, right? Temperature for the hot and cold water. Right now, when we come to the question, and yeah, one more thing, if we have to find out the logarithmic mean temperature difference as per or the mean temperature difference of the temperatures, the formula would become del Ti minus del Te divided by natural log of change in temperature at the inlet divided by change in temperature to the outlet or the exit point, right? So now here we have Thi is equal to 102 degrees Celsius THE is equal to 65 degrees Celsius, TCI is equal to 25 degrees Celsius, while TCE is equal to 42 degrees Celsius, right? And for the delta Ti, if we try to calculate it, it would become THI minus TCE, right? And it would be 102 minus 42, which would be 60 degrees Celsius, right? Similarly, if we find a temperature difference at the exit point, it would be THE minus TCI, right? Should be 65 minus 25 equal to 40 degrees Celsius, right? So these are the temperature difference for the fluids at the entry point as well as the exit point, right? While at the entry point it is oil, while at the exit point it is at no sorry, for the first entry point like the THI, it is the hot oil, while the cold water enters at the 25 degrees Celsius, right, which is TCA point, right? And we have to find out the logarithmic mean temperature for these two different fluids, right? So next, if we apply the formula as we have written before, how much it would be logarithmic mean temperature difference, it would be 60 minus 40 divided by natural log of 40 by 60, right? And if we solve this out, its answer would be near to 49.3 degree Celsius, right, which is the logarithmic mean temperature difference for the fluids which has been given out, right? So